The M6 heavy tank was one of the most extensive and ambitious projects of the early period of World War II in American tank development. The vehicle was designed as a potential breakthrough tank of large caliber, intended for combat operations against fortified defensive lines of the enemy. Although the M6 was not adopted into service and did not participate in combat, the project is considered an important part of the development of American armored vehicles, as it laid the foundation for technical approaches later used in the design of heavy and advanced tanks. The main task of the T-1 project, the future M6, was to create a heavy tank weighing over 50 tons that could combine powerful armament, advanced armor protection, and high mobility for its class. At the time development began in 1940, the concept of a heavy tank in the United States had not yet been formally established in doctrinal terms. Leading officers of the armored forces considered such a vehicle as a means of independent offensive action and breaking through fortified lines, similar to the French Maginot Line or German defensive positions. The concept envisioned the creation of a tank armed with two guns, a large caliber 76 mm and an additional 37 mm, which reflected the combined fire doctrine adopted at that time. The vehicle was to have a powerful gasoline engine, a massive hull, and mobility that was high for a heavy vehicle by American standards. The M6 hull was a cast-armored structure of a complex shape. At the time of its creation, it was one of the largest single-piece cast armor hulls in the world. The use of large-size casting allowed for a reduction in the number of welded seams, increased the hull strength, and decreased the likelihood of failure under impact loads. Main characteristics of the hull. Hull type, single-piece cast, with additional welded elements. Hull length, about 7 m. Width, 3.1 m. Hull height, up to the roof 2.4 m. Overall height with turret, about 3 m. Combat weight, 57 to 58 tons, depending on modification. The internal layout was based on the classic American scheme of the time. The engine transmission compartment was in the rear, the control compartment was at the front, and the combat compartment was in the center. The front compartment housed the driver and his assistant. The central part of the hull served as the main combat compartment, containing the turret ring, ammunition, and crew workstations. The M6 armor was one of the most powerful among American tanks in the early years of the war. Its design took into account potential actions against German anti-tank guns. Armor thickness. Hull front, 83 mm, solid cast plate. Side plates, 44 to 70 mm. Rear, 41 to 57 mm. Roof, 25 mm. Bottom, 25 mm. Turret front, 89 mm. Turret sides, 67 mm. Turret rear, 67 mm. Gun mantlet, up to 90 mm. The cast design allowed for optimal sloping angles and reduced the likelihood of shells ricocheting. Despite the impressive numbers, the tank's protection was no longer considered absolute by 1942, as enemy anti-tank weapons were rapidly improving. However, at the time of its design, the M6 armor was of high quality and far surpassed the protection of U.S. medium tanks. The M6 turret was fully cast. It had impressive dimensions, sufficient internal space, and several ports for mounting machine guns and observation systems. Turret features: 360 degrees rotation, manual and electromechanical drives, reinforced mantlet, ammunition storage compartment, early type commander's cupola with multiple vision devices. The turret was designed to mount two guns, the 76 mm T9 and the coaxial 37 mm M5/M6, as well as 1.50 caliber, 12.7 mm, hull-mounted machine gun and a 7.62 mm turret machine gun. One of the most complex and controversial features of the M6 was its combined armament. Main gun, 76 mm T9. The 76 mm gun was designed to combat fortifications, light and medium tanks, as well as to support infantry. Specifications of the 76 mm T9. Barrel length, 50 calibers. Ammunition types, high explosive, armor-piercing, subcaliber. Muzzle velocity, 732 meters per second. Shell weight, 6.8 kg. Armor penetration, up to 90 mm at 500 m with a normal hit. For its time, the gun was quite powerful, but competing countries were already moving to calibers of 88 to 122 mm. Secondary weapon, 37 mm M6. The 37 mm gun was paired with the main gun and intended for use against light armored vehicles and infantry. Combining two guns in one turret complicated the design, made crew operations more difficult, and did not provide a significant advantage. Machine guns. One 12.7 mm Browning M2 HB, coaxial or hull-mounted. 2 to 3 7.62 mm Browning M1919A4. Some versions were equipped with an additional rear machine gun. Overall, the armament was quite substantial, but the redundancy made maintenance and combat operations more complicated. Wright G200 engine. Powerplant, Wright G200 aircraft engine, radial, with 825 horsepower. This allowed the tank to achieve a high maximum speed for its class, up to 35 km per hour on the highway. Engine specifications. Type, gasoline, 9-cylinder. Cooling, air-cooled. Power, 825 horsepower at 2,300 revolutions per minute. Displacement, over 27 liters. Fuel, high-octane aviation gasoline. The engine provided decent torque, but it was extremely fuel-hungry and required a high consumption of air. Transmission. There were two versions. Electromechanical, T1E1, the engine drove a generator, which powered electric motors to turn the drive wheels. Hydromechanical, T1E2/M6, a classic complex transmission with an automatic gearbox. The electromechanical system was technologically promising but extremely expensive and heavy. The running gear of the M6 was based on the American tradition of using bogies with vertical spring shock absorbers. Running gear specifications. 7 road wheels on each side. Drive wheel at the front. Large idler wheel. Wide tracks for weight distribution. Track width of 660 mm. The running gear provided satisfactory mobility, but with the vehicle weighing almost 60 tons, the load on the road wheels and tracks was at the limit. Maximum speed, 35 km/h. Average speed over rough terrain, 15 to 18 km per hour. Range, about 160 km. Specific power, 14 to 15 HP/ton. The M6 crew consisted of 5 to 6 people. Commander. Gunner. Loader. Driver mechanic. Assistant mechanic. Sometimes an additional machine gunner. Such a number was due to the complexity of the armament and control. Despite the weight, mobility characteristics were considered sufficient. The production of the heavy M6 tank was planned to involve several hundred units. However, actual testing revealed a number of serious problems. Excessive weight. Complex and unreliable transmission. Poor crew ergonomics. Overloaded armament system. Insufficient armor by 1942 to 1943 standards. High cost of manufacturing cast hulls. At the same time, the concept of cheaper and more versatile medium tanks of the M4 Sherman series emerged, which were easier to produce and maintain. As a result, the order was cancelled. About 40 vehicles of all modifications were built. From an engineering perspective, the heavy tank M6 was an ambitious but unsuccessful project. It included a number of innovative solutions, from the use of large castings to an electromechanical transmission, yet the vehicle's actual performance fell short of expectations. Key advantages. Powerful engine. Impressive armor for the early stage of the war. Diverse armament. Promising engineering ideas. Sturdy cast hull construction. Main disadvantages. Excessive weight. Production complexity. Overloading of armament. Imperfect transmission. Poor maintainability. Insufficient manufacturability. The M6 heavy tank became a transitional link in the development of American armored vehicles. Despite never being used in combat, it gave designers an understanding of the real limitations of heavy tanks, their complexity, high cost, logistical difficulties, and technological demands. The M6 project laid the groundwork for further developments, including the more successful post-war heavy tank M103 and the experimental T-29/T-30/T-34 series vehicles. The M6 can be considered a technical experiment on a national scale, bold, large-scale, but not aligned with the actual needs of the Army during wartime. However, as an engineering achievement of its time, the tank serves as a worthy example of striving for a balance between firepower, armor protection, and mobility.